goes over to the right-hand side of the page, that's expressed in dBm, the actual noise floor. This is the minimum amount of light that receiver can detect and decode usable pulses at that receiver. The NH2001 FOM, which is the multi-mode fiber interface, is system down to 32 dBm. If you take a look at the 3012 GESXM, I think there was a change there recently. GESXM, that might be a boo-boo. We'll just say it's minus 19 for now. And then the 3012 GELX S3 receiver is sensitive down to minus 22 dBm. Those are some typical numbers you see in receiver sensitivities. Transmitter powers are typically published as ranges. Again, the receiver thresholds are pretty finite. We're just going to receive down to minus 32 dBm. If it's minus 33 coming in the receiver, throw it away. It's not going to work. You need more power into the receiver. The transmitter power will typically be published as a range, with minus 19 being on the low end, minus 14 being on the high end. Always working towards zero, is the higher the power. If you take a look at the conversion, there's a conversion chart in there. 1 microwatt represents 0 dB. And we don't want to talk about conversions of dBm and dBmu because that gets pretty complex. You take, I think, 10 cosine the output versus the input, you end up with dBmu, or I don't know, some kind of thing we'll never ever use. You see that expressed in a range. GESXM is as a range that you're guaranteed somewhere in the operating range of minus 15 to minus 8 or 0 plus 5. Again, here's some of your carrier class optics here, from 1 milliwatt up to 5 dB over 1 milliwatt of actual output power. That's definitely not one that you want to go staring into. Now, when you're designing your link budgets, ideally, you want to shoot for the lower number, the lower the output power, because this may come in handy a little later on the high side of the range. If you take a look at NBase optics, he's going to manufacture these LEDs. The manufacturing process, he's operating that production is going to yield a certain distribution of optics that'll fit that grade. It's always best to play the safe side when you're laying out a physical plan or laying out a design, is to use the lower number in all the pieces. Okay? So if you need an extra 3 dB that may be there, then you've got it. You certainly don't want to design to this figure here and find out that actual LED is only minus 17. So always design for the lowest output power range according to the sheet here. Another important factor in calculation is saturation. Saturation is the specification that's measured at the receiver of too much light to the receiver. When you saturate enough to the receiver, you basically are distorting the capability to decode evenly the ones and zeros. So what you're concerned with there, again, is a very finite number. You don't want to see anything any more powerful than minus 6 dBm at that receiver for 2001 FOM. If you do, then you start looking at attenuators or some way to attenuate that signal. Those are typically inline devices and values of 5 dB or 10 dB. They're typically in 3 dB increments, 3 dB, 6 dB, 9 dB, and so on, which you can pad it down, if you will. Which brings up another concern. Just make a note that if you're padding at 850 and 1300 nanometer, you're okay. Padding gets a little tricky at 1550, especially if you're padding close to the emitter. Because if the pad that you're using or the attenuator that you're using isn't properly aligned, you may get some reflection off of that and destabilize the laser if you're doing that close in. So you typically tend to pad or attenuate as close to the receiver as possible instead of at the transmitter side. So when you're doing that, try your best to do all that work at the receiving end.
Actually, you use the fiber at the minimum of the best. Wouldn't bring them to this level.
Yeah, pad it down with just lossy fiber or jumper. Now, keep in mind that saturation can be the #1 killer to evaluations. If you're ordering up equipment, specified equipment to go into an installed site that might be 30 miles apart, the customer all of a sudden wants to see this working on the bench, side by side. To take an S3 optic for a 6-foot jumper and pump it into a receiver right beside it, that's the formula for trouble every time.
I think we need to produce a special one. Yeah, special 6-foot jumper.
How about an S2 or an S1?
Well, with an S2, let's take a look. If you go down here at the S2, take for instance an S2 at the 3012, the saturation there is only minus 3 dB. The minimum output power is minus 7, since you're okay. The most it can put out is minus 3. So with a minus 3 output and a minus 3 saturation, yeah, you can use your short jumper on that and not worry about it. But if you go down to the S3, you're going to kill it every time. Pump too much power into the receiver. You wouldn't believe the amount of time that's been lost in evaluation attempts by both customers, SCs, and everywhere else that fully understand or take into consideration, the properties of the receivers and so on. There's been times sweating it too where you didn't think you had enough light. So let's take a look at some loss budget examples. Take a look at example 1. You follow on, look at the product on the sheet here. Take a look at the 2001 FOM. We replace the NH with an SX for a Xyplex equivalent. Another important factor too is to consider the actual wavelength of the device. And that's also a column on this chart as well. Because you've got to take a look at the properties of fiber that you're actually launching that 1300 nanometer signal network to actually come up with the overall budget. 1300 nanometers, my receiver sensitivity is minus 32. My output power is anywhere between minus 19 and minus 14. Another little figure here is called overhead. This is a pretty healthy amount of power that we sort of put in our back pocket here to allow for several factors. The average installation, the average number of connectors, patch panels, an average loss of fiber is all considered in that 5 dB. Also was considered as aging. This will tend to degrade slightly over time. The output power, due to aging, that curve, power output curve, you might start out at minus 14 on the initial install. 2 years down the road, this might be down to minus 16 due to an aging process in the rotor itself. So this that range allows for that aging. This 5 dB gives you the extra overhead. By taking all of this into consideration, you net an 8 dB usable budget just on the fiber itself. Because in the 5 dB, you've already considered the connectors and everything as part of that. But you really get, don't just always take that for granted. You really have to take a close look at the physical plant to make sure that you don't have any abnormally high losses.
What do you normally estimate for connectors or patch panels?
In a typical installation, we'll say point-to-point, where that 5 dB is derived from. You typically come out of your premises equipment, short jumper cable, hit the panels. That's one set of connections there. Backbone, and we've allowed for maybe another NBF before it gets out of the building. So that's another break. Hits the backbone. Is dark fiber going to a central office? The bell's offering the dark fiber. You might get a couple more panels there. And basically, from that point on, you're looking at a mirror image of that first link. So with those those interruptions end to end, you can pretty much chew into that 5 dB fairly easy.
Each connector is usually like 0.05, and that's what the average is.
Depending on the wavelength, the 1300, 1550, or 850.
Elastomeric was considered anything above 0.1 as
Right.
on the connector.
Yeah. One important note Odin brought up our last session. Anything that you've read on fiber optics that's more than 2 years old, throw it away. Because the technology continues to evolve and change. Connector losses, elastomeric splices, fusion splicing, the technology continues to improve. An elastomeric splice 5 years ago might have been a 2 dB insertion. Today, you're down to tenths of a dB for that type of technology. Now, if you're dealing with fiber plants that are that old, then that material might be useful because you're dealing with the older technologies. Okay, so let's look at the results of that. We'll take that 8 dB. The typical link loss for fiber at 1310 nanometers is 1.5 dB per kilometer. The minimum distance based on the low edge power output, minimum distance, I'm easily going to do 5 kilometers end to end. Okay? If I want to gamble a little bit and start flirting with the high side of that output on that LED or the laser, then if I use the higher number, well, we can gamble maybe go up to 8 kilometers for that. But somewhere in there is that fairly safe range. If it's a private, fairly new installation, you're not doing CO hops, it's private premise 1, patch panel, backbone fiber, patch panel, premise. then you don't typically have as many interruptions in the fiber as you normally would, and it allows you to maybe dip into that 5 dB of budget, pick up a little extra distance there as well. So those are some of the typical distances you'll see on the 2001. Another example, let's take a look at some of our S3 carrier type sockets at 1550 nanometer. Sensitivity of that receiver is 22 dBm. The output power range is from 0 dB to +5, minus 5 dB of overhead. My minimum dB budget on the S3 pair is 17 dB, and that results in to a range of basing my link loss at 0.2 dB per kilometer anywhere from 85 to 110 kilometers, the span of distance. Now, when you're operating at 1550, the slightest variation in connector loss, link loss to fiber, so on, will make a dramatic change on the end-to-end distance of this. If you were to take and simply go add 0.2 dB per kilometer, just 0.2 dB per kilometer on that fiber, I'll cut those distances slap in half. Our range then is between 40 and 50 kilometers. So, you really got to make sure that you've got real tight controls over these kinds of fiber plants, because those little minute changes there can be killers. Conversely, as the fiber keeps getting better, Mark and I lucked out on one. We worked with one of your SCs up in Michigan a few months ago, Ed Cott, and we based all our calculations on this 0.2 number here. We were extremely nervous that we had to flirt on this high side here to make sure that we're going to do that distance. And come to find out, the actual fiber line came in at around 0.15 dB per kilometer, so we had plenty of headroom in terms of budget. That was the Phone Michigan installation. I don't know if you heard anything about that. That resulted in what, 30 12s, I believe?
Yeah. It was 60 miles of distance, was the fiber.
Yeah. It was the fiber in from Saginaw, Michigan down to Michigan on the Flint. It was one continuous run of fiber.
Yeah.
Single.
Okay. Now you said there was 60 miles, that was an unbroken band?
Unbroken fiber. Well, there's splicing all over the way. Look at a couple of things about what causes loss. Coupling of light source, whether it be an LED or a laser device in the fiber. Typical connector losses. Again, this is going to vary widely. These are just some typical values: 0.75 dB or a dB and a half per mated pair on both ends of the fiber. Splice loss is a very, very worst case. They're going to be 0.3 dB less than splice loss. Those are numbers I typically use for budgeting. That gives me a little more room in my back pocket, even though the splices might be coming in at less than a tenth of a dB. I'm still going to use 0.3 as some of my factors, just to keep a little extra room in my pocket for some other variations there. Connector loss, primarily, number one target is going to be due to dust, dirt, and cleaning residue on the connector tips, and is more evident on the 1550 S3 stuff, as far as any kind of problems there. The main killer can be just airborne dust particles. One of the biggest problems, and I've seen it happen by anybody that's out there, but it's the biggest sin in fiber at 1550 is to leave those connector tips unterminated, leaving the plastic tips of those fiber. Just airborne particles. Now just think about this for a second. You're leaving exposed a little connector tip that has a core of only 9 microns in diameter,
Which is smaller than the dust. The particle of dust is bigger than this.
Airborne dust particles of fibers can actually completely cover that 9 micron core. Okay? Now think of cleaning residues. They're doing this number here. Don't do that.
Tim, I usually just,
Yeah.
I hope you do it with the other laser film though.
oh,
That's right, yeah. Earring in your
Do this is like that.
oh, okay, your last name, then, use the fiber installer. Yeah, the one that pointed in your lip, maybe choose a fiber installer, just decide to put it out in the
What
ring.
dB loss do you get from that?
Blowing the connector tip end off is another no-no, because most of the computer grade canned air that's out there, propellants in that leave typically a residue.
You still have three of them, I don't know what about now.
Well, even the freon's an issue too,
Yeah,
because of
I know.
condensation problems. Cotton swab fire, big no-no, get rid of them. Don't use them any of that. I've actually seen customers out there with cotton swabs looking at the 3012 and doing this number here in the connector on the mating side of the equipment. So You really got to educate the customers too on the care and maintenance of the optical interfaces. And human skin oils, Apple ladies, you don't want to do anything like that. It's just, all kinds of problems that can add to this. So the best policy is clean them. Keep those protective caps on the equipment jacks, the low plugs that go in there when they're not in use, and also on your jumper fibers, and also on the patch panels that customer prim too. First thing I see happen when people start unplugging patch bays to plug in connectors, those dust caps, where do they go? Right over the shoulder. You want to make sure you tuck those back into the patch panel so that you can use those if you ever have to unplug that connector. Clean according to the manufacturer spec. Every manufacturer has a precise cleaning procedure and cleaning kits. If you can't get the ones from the manufacturer, you can be fairly safe that you can use Tex wipes, which are a fiber-free cleaning pad or alco pad with isopropyl, 100% isopropyl, so there's no residue to clean those connector tips. So basically, if you care and feed and maintain those connectors accordingly, we'll have nice repeatable results. Let's see, let's blow ahead a little bit. Here's some other loss contributors to connector issues. Here at the end is the number one cause: dirt and finish and crud in that. Alignment issues, coaxiality, axial runout. You've got bending of the fiber. This is typically caused by not dressing the fiber out of the rack. Coming out of the customer equipment, you roll it up in a roll, let the weight of that roll tug on into that fiber. And this will result in basically axial runout of the fiber itself. Cores mismatched. You've seen people trying to plug 50 micron into 62.5. You're going to end up with some incredible losses here. If this is the transmitter side, you're coupling in this direction, more loss than if you're transmitting in this direction back towards the receiver. We won't see symmetrical losses in an arrangement like that. End gap, you're not plugging in all the way, hasn't been properly terminated or polished type of thing. And the only exception to loss is, in certain cases, there will be on purpose determinations of this style here, where you have an end angle put on the connector itself. And most of the 1550 optics that come from MRV, there will be an intention to offset the polishing of this, because what this does, if there's, say for instance, this is the emitter side at 1550, any light coming back in, actually that's the emitter side here, coming back in, if there's any reflections off the connector tip itself, the reflective component goes off in this direction, and not back down the fiber. So I mentioned earlier, if you get any kind of connector tip reflections at 1550, those reflections go back into the cavity and destabilize the laser. So in those cases where you're really, really hot optics, you might see some type of offset or an angle on the tip of the connector. Okay. Connector losses. Another big contributor too is in the office complex, under carpet cabling, modular fiber components, stuff that gets dropped down the wall and stuff like that. Those are incredible sources of losses there. Okay for multi-mode and short haul stuff, but we get into other things, it's a big issue. This is probably some of the stuff we're going to talk a little bit about tomorrow while some of the lab is going on, while some of the breaks are going on in the lab. Take a look at some fiber optic testing equipment. Typically a transmitter, cable plant fiber loss, and you're measuring the receiver and comparing the amount of light here with the amount of light you're transmitting down the fiber, determining what the actual fiber loss is in the plant. In testing the fiber, you typically, another common mistake is taking the fiber under test and plugging it directly into the source, and then taking the other end and plugging it directly into the meter. The types of emitters in these devices, especially in multi-mode, you need to launch this until fiber first and launch cable for what we call modal conditioning and for repeatability. Because once you do that, this becomes, I plug this receiver into here, I can set up a known benchmark for that link fiber there. The same thing with this connector here. And by plugging this in, then I can measure the delta between the source and the receiver to come up with that.
Actually kind of talk about collectively with all of you the approach and get your feedback and try to help you understand exactly how this actually works. And then we'll go in the lab and we'll actually do it. Nice marketing blurb here. Xyplex XS series switches are layer 3 switching leaders. Characteristics of a router basically is to connect two subnets together, isolate broadcasts, better control of network security, eliminate loop control, and allow for scalability. Direct IP switching brings to the table wire speed performance, broadcast isolation, provides a high level of IP security, acts as a DHCP relay. Typically what happens when a client wants to talk to somebody, this slide depicts that with a router, typically has to talk to a default gateway, and then the default gateway replies back with his MAC address, and then once the MAC address has been supplied back to the end station, then the conversation unicast to the router, but will be forwarded to the end station, to the subnet that it's directed to. Whereas opposed to direct IP, it's an ARP is sent out, and then it's unicast to the end station. Connection set up. Host A needs to communicate with host B. It sends out an ARP, which is directly connected to the direct IP switch. The switch intercepts the broadcast and supplies back the MAC address of the end station that he wants to talk to. Basically, he acts as a proxy for that client. And then it's unicast at wire speed. So basically, the question is, well, how does the switch know how to supply back the MAC address of a device that could be several subnets away? As soon as you turn on direct IP, he does what our routers do, which is gleans the wire. Every ARP that he sees coming across the table, he adds it to the ARP table. If he doesn't see a particular ARP that comes in, which isn't in the ARP table, what he'll do is he'll forward it only to the route that actually is supporting that subnet. So as opposed to an abridged environment, it would get flooded across all ports. You will build a table, which is considered a routing table in direct IP, that will forward that particular ARP to the route or to the network where that end station belongs, which at that point in time would get serviced. And then the packet would be sent back to the requester, and it would be unicast at that point at layer 2 switching. Okay, so in a routed network, we've got 3 segments here. We've got 3 different subnets.
You don't have this slide, by the way.
Yeah, you don't have the slide. This is going to be part of the dialogue we're going to go through right now. If host A wanted to talk to host B, how would he do that in a routed network? What would his configuration be in order for him to do that? Any of you can pipe in. I'm looking for some dialogue here.
Just send it to the default gateway.
You send it to the default gateway.
Well, the first thing he does is applies his address and the address of the host he wants to send it to, applies the mask, determines that a route occurs, determines that it's off of his network, sends it to the router because that's his default gateway.
So in this case then, basically each station can only talk where? Only on his local subnet, correct? Depending on his mask. And most implementations would dictate that they would have the class mask that associates to that subnet. So it would be a 24-bit mask probably in this implementation. Okay. In a switch network, how would host A talk to host B if he still had that same mask applied? How could he talk to him if you needed him to talk to those 2 different subnets? How could A talk to B? What could happen? How could you achieve that in a switched environment?
Roll the mask back.
And you already know the answer. It's on. I'm trying to get the other folks just to, yeah. So, looking at that picture, how could you get host A to talk to host B?
Flatten out the network.
Let's talk about IP configuration. What parameters do we define in a PC client for him to communicate? We define the mask and we define the default gateway. Correct? The default gateway act facilitates that end station to communicate to a device off net. But in this case, we have one Class B network, correct? Which is 140.179. So depending on the mask, can really dictate what end station can talk to what end station. So if you roll the mask back and make it a Class B mask, then basically what happens is that these devices can communicate to each other because when it parses the packet or the stack looks at the request to that end station, if he sees it as a Class B mast, then he assumes that it's X amount of hosts, and he doesn't care, because it's not subnet. But in this configuration, what separates this from a routed environment? If you back the mask off and you leave it as it is right now. Well, what's the difference between the two? In a routed environment,
Broadcast domain.
that's right. In a routed environment, you contain the broadcast. In a switched environment, it gets flooded. But we just went through on the previous slides that direct IP, when it turns on, contains broadcast. So when a broadcast comes in, it's isolated to that segment. So the bottom line is, in order to implement direct IP, you have to have the ability to allow the clients to talk to everybody in the network. Now, this slide only demonstrates that by backing off the mask, you could talk to everybody in that particular IP subnet. But there are implementations where customers have multiple IP addresses in their network. So given that, how would an end station on one subnet talk to another end station in another subnet? What could you do on the PC configuration side to allow him to do that? So he could talk directly to that end station.
If there were another class, like a class A and a class B.
Correct. How could we do that?
Make PC the router.
Make the PC his own default gateway. So now, if you have the ability to do that, and if you have the ability to contain ARPs, then you have the ability to perform at wire speed. And that's what direct IP really does. But there's a price that has to be paid, and that is you have to manipulate the PC's configuration. Given that, moving on here, this basically just talks about what we just said. Okay, there's two ways to actually manage an end station configuration. Either you have to manually do it, or you do it through a protocol that facilitates assigning IP address and configuration information, and that's DHCP. We all know what DHCP is, I believe. It's nothing more than a protocol that allows you.
Slides are missing here. It's the second slide missing from your original. This is number 3 missing.
Probably haven't got there yet, I don't know. Well, in any event, DHC is a protocol that allows clients to participate with the dialogue with the DHCP server to have an IP address assigned to him, which obviously is a tremendous benefit for any network administrator who doesn't want to have to worry about IP administration. Okay. What happens in the direct IP environment behind the scenes is basically this. Each direct IP that's participating in direct IP will have subnets attached to its ports, just like you would with a router. These subnets are represented by what's called an IP VLAN. And these IP VLANs can be configured on multiple ports to support multiple end stations. It's not like on a router where you have one IP subnet and you have to support that whole user community. You have multiple ports to support one IP VLAN. If you had 2 direct IP switches in your environment, and each one of them had their own IP VLANs, then you would have to create on each switch static routes so that the 2 switches participating in direct IP would know how to forward a request that came in for an IP VLAN that wasn't locally attached. Once the IP VLANs and the static routes are up, the runtime code, the direct IP code, automatically starts ARPing the network and builds that table that we talked about a little bit earlier. So when a packet comes in, it doesn't have to go learn it. It's already learned where that route's located. And then basically when a request comes in, switch looks it up and forwards it or services it. And in essence, reduces the broadcast of the network. all direct IP switches listens for ops, so any PC that's advertising or trying to find a resource, it will get learned, put in the table. Anybody else coming in requesting for that IP address, if it's learned, then it will automatically service that client. If not, then it actually will get forwarded. If end stations are participating in DHCP, the administrator can make decisions to modify PC mask or gateway information. Okay. And failed to mention that part of direct IP, there's really three components to it. There's the direct IP that actually gleans the wire for all ARPs. The second part of direct IP is the DHCP relayer. And the third part of direct IP, in terms of its functionality, is the security. Okay, the DHCP relayer basically is an application that allows the switch to actually change the characteristics of a reply that comes back from a DHCP server to a client. And what I mean by that is a DHCP server has the ability to create scopes. And a scope is nothing more than an address representing an IP subnet. And that address allows you, or the scope allows you to create a range for that IP subnet. So if you got 5 IP subnets that you have to service for users out in your network, then you would create 5 scopes, and within each scope you would define the range of addresses that would be available within that scope, along with the characteristics that are allowed with DHCP server, which there are 70 parameters, such as default gateway, time server, all the parameters that you would typically use for instance, boot pig. It's just an extension of it. What the relayer does is that the DHCP server will pass you the IP address, will pass you the mask, and could pass you the default gateway if you specify it. Well, we just talked about that if a client has to have the ability to communicate to everybody, and the DHCP server is passing back information that requires that end station to belong to a specific subnet, such as 255, 255, 255, well, once that client gets that information, he's not going to be able to talk to anybody except for all stations within his own subnet, which somewhat self-defeats the purpose of direct IP. So what happens is that there's a relayer built in there that will massage the packet coming back from the DHCP server and allow you to make a decision. And the decision is, do I want to back the mask off, or do I want to make the PC his own default gateway? So based on your network configuration, you have to make a decision what it's going to be. Now the easy answer probably is, for most people, would make it the default gateway, and there isn't all that much calculation to kind of figure out. So you could do that. Or you could look at it from a different standpoint and say, well, from the one Class B network, then I just back the mask off and I'll let the DHCP server provide all the clients who the default gateway is, because that gateway is going to be in the same subnet, the same class IP network. So there's a thinking process that has to go through here, that you have to go through to determine exactly how you want the relayer to massage the packet. But once you make that calculation, he'll take the packet, he'll parse it, he'll go to the appropriate fields within the DHCP portion of that packet, stuff the information in, and then forward it back out to the end station, and at which time the end station will have not only his IP address, but the ability to communicate to anybody in the network that he needs to. So that's basically what this slide represents right here. I'm not going to read it verbatim, but...
Just a comment on it, FYI.
Yeah.
The Microsoft DHCP agent does not, in the standard default scope, does not configure for a default gateway.
Correct.
So if you don't configure a default gateway, direct IP does not add a default gateway for you.
Right. He's looking for the bits to reset, and if there's no bits set, then he won't interject and add that address in. Yeah. I was going to get to that, but we weren't there yet. That's okay. It's a good point. Any questions so far? Does it kind of make sense? Yes?
The last couple of things that you said about it, you said that the direct IP switch injects the appropriate information into the packet as it, so it can get to the client.
That's correct.
Are you implying that in a normal situation where there was not a switch, direct IP switch in the middle between server and client, that the server communicates to the client back via a broadcast?
No, it would be unicast back. What basically happens is that you create your IP VLANs that represent a particular IP subnet. You've got a client who has no IP address. He boots up, he sends out a DHCP discovery packet. First thing that happens is that it comes in on a particular IP VLAN port, okay? The direct IP switch says, oh, wait a minute, I've got to represent this IP subnet. So what he does is he stuffs his address in the gateway address or the DHCP portion of the packet. He looks it up in his table, he says, where's my DHCP server? Which you have to tell it where it's located, what's the IP address. Does it look up in this table? Do I know where it is? Do I have an op entry? Yes, it's unicast. No, then I forward it to the appropriate subnet that it needs to go to. At which time, DHCP server, once it gets the packet, he parses the packet. He says, oh, this packet belongs to this IP VLAN. Do I have a scope that represents that? Yes, I do. What is the address range associated? What's the next available address? Provides that information and then all the other attributes that are associated with that. The packet is then sent back to the switch, at which time, since you have the relayer turned on to tell it to either massage the mask or to modify the gateway address, he'll parse the packet. He'll parse every packet that comes in there because you have that option turned on, and he'll stroke it accordingly, and then he'll forward it out to the port that it has to that represents that that request that came in.
What exactly does the stuff in there?
He stuffs in the appropriate information. He goes down to the DHCP portion of the packet. It's nothing more than the DHCP information within the packet, and there's several attributes within there, and it stuffs in under the DHCP gateway. I can exactly look it up if I had to, and he puts in either the IP address that came back from the DHCP server, which would be the default address that you set, or you would already predefine what the mask would be, and he'd stuff that mask and peel off the mask that was assigned by the DHCP server. So it's either the mask that he massages, or he massages the default gateway address. At which time the end station gets it and now has the ability to do everything that we want it to do. Anybody else? Basically, what I thought, this is, my presentation and my ad lib don't kind of sync together because I thought it made more sense to kind of do it from the heart as opposed to read it off the slide. And with some feedback from you guys, you could actually tell me, you know, if I was on track and ask the question. So I'm not going to kind of reiterate what I just got finished talking about. And basically, that's it for direct IP, other than the fact that I didn't bring up and I didn't add it to the slide because I hadn't had a chance to test it, is the default route. We talked about how we can get PCs to communicate to everybody within the land environment. And that land environment could be a building, it could be a campus, it could be a metropolitan area network. It's just the land environment, and that's when you would use this. But we didn't talk about how do you get off net over a wide area network. And there are a couple of ways of actually doing that. One is that through Megavision, when you create your static routes, you can actually create what's called a default route. And it's just like you would on a router, 0.0.0, and you tell it what IP address, the next hop would be the IP address of that router interface. Or there is another way to do it, and that is that within the configuration from the command line, you could actually configure the gateway address of the switch. So let's say that the switch needed to talk to somebody that was off net based on the IP address that you gave it. Well, just like any other bridging device, you have to tell it what the gateway address is to allow him to resolve that address. Well, direct IP and the IP state machine kind of coincide together in such a way that if you don't define the default route, but you do define the gateway address, that the direct IP switch will say, I got a route that came in, I don't know how to get there, but how would I get there? By not looking at the routing table, by looking at another facility, and the facility is this gateway address capability. So the two ways of doing it, my recommendation in terms of simplicity and ease of understanding for the customer would use the resource that's available to you, and that's Megavision, and do it through there, because you're gonna draw a lot of questions from a customer saying, well, wait a minute, I don't get this. You know, why am I saying that, you know, I'm gonna define the gateway address of the bridge, and you're gonna use that to resolve routes? That doesn't make sense to routing people. I had a little problem with it yesterday, and I kind of talked to the engineer about it, and then, you know, he kind of level set me and said, well, you know, we're kind of routing, we're kind of bridging here, so I took it for face value, but my gut feeling is if I was to present it to the customer, I'd present it based on the tools that are available to me for direct IP, as opposed to kind of having them go off course and go into the command line and set it this way. There may be instances where you may need to do that. I can't think of one right now. I mean, I don't think well, actually there's a bug right now in Megavision that won't let you do it anyway. So we'll have to do it the other way, and that is to set it. And that's being fixed right now. You can't set it to Megavision.
I have a customer question. Assuming a VLAN, a direct IP VLAN,
Yeah.
spans X number of switches with the same IP VLAN on multiple switches, does each switch have to be configured with a unique IP address on that VLAN?
The answer to that question is yes. When you create an IP VLAN on a switch, you give it a IP address.
So each one of those IP addresses has to be unique and from the valid IP address pool, which
Right,
subsequently...
because depending if you want to manage it, let's say you wanted to manage that device, and you were to use, and you had this, for instance, this lab that you're going to do does have an IP VLAN that spans. It's the backbone IP VLAN. And typically that's what you would have anyway, one would think. Right?
Right.
It would be the backbone. So if you wanted to manage it, think of it this way, if you tried to manage it through Megavision, you wouldn't be able to, because you would have duplicate IP addresses, and you wouldn't know how to find that particular switch.
Or no
If,
access.
excuse me?
Either that or no access.
Or no access, yeah. Yeah, but no, I don't think you would do that. That doesn't make sense. I would configure it as if you were configuring a routed network. It's basically the same thing when you really peel back everything. You've got IP VLANs locally attached. You've got static routes that are actually allowing networks to be able to be resolved. So I wouldn't add a level of confusion for the customer. I mean, you might be able to do it, but I don't think so. And I wouldn't.
You might be able to do it, so your question is whether it's even possible to do.
I would say no, but I mean, you never know until you prove it out. I mean, you could do it, right? Let's put it this. No, actually, you wouldn't be able to do it. And the answer to it is this: when you create IP VLANs, what does it do after it finishes creating IP VLANs? Oh, actually, when you create static routes, when you create static routes, it arcs everything. When you create an IP VLAN, it doesn't, because you add. Think about that. Yeah, you could do it, but you couldn't manage it. You could get away with it, I think. You could, but it wouldn't make sense. You'd draw a lot more questions from the customer saying, why are you doing that? As opposed to justifying why you're doing it. Right?
No, I see a value in it. I mean, your
Okay.
backbone's like that. Your backbone is that scenario. Your backbone has multiple switches.
Right, and if I want to manage it though, if I want to manage the backbone, I've got the same IP address, I can't.
Right.
Okay, so,
So the only drawback is then you have to use an IP address for each switch.
well,
And
the
then-
only way you could manage it, if you
No, I understand, I was just asking.
you'd have to use the private interface,
Right.
right? Or you would, there's a couple ways of doing it, but it gets ugly. So I wouldn't suggest doing it that way.
Wait a second, if you define the backbone, which brings the port to participate in the actual backbone,
Mhm.
and the switch itself has an address in class A, and you provide all the routing and all communication, why do you care about the actual IP address of the switch? That's only for management. It doesn't participate in the direct IP.
Oh, sure it does.
So
No,
you-
it doesn't participate, it doesn't participate from the standpoint that it doesn't get created as a local IP VLAN, but it does get added to the routing table.
Yes, but if you provide the routing table, let's say the port 1, switch A, which is the DLE, connects to port 1 on building B, those must be on the same subnet, right? On the link must be, both sides have to be on the same net, just like routers. On each end of the link, you have to have the same subnet. It doesn't matter what the management IP that you assign to the switch.
I don't disagree with that. He's asking if you can make it the same IP address across the board.
No, you cannot. And the thing is, if you are...
Well, you could if
he
you
wants-
weren't using management,
No,
that's
but
the
he
point.
wants to save IP addresses, so if you take, for instance, a class A and you assign it as your management, and you assign one port in every switch for that, you assign that same subnet to it, you will have access to all the switches, they could be on a 10, on a class A network.
See, the value of
I
it
don't-
is,
I'm
what if,
trying to
the
think.
value of it is
I
you
don't
got
think
sales
that's
and
right.
engineering.
Yeah,
And you say, okay, I want sales in this subnet and engineering in this subnet. Now, if you put them on their own IPs, in an IP classified network, now it doesn't matter where you put them physically in the building. It doesn't matter where they're plugged in, but logically, they all still have the same, they're still in the same network. So you can maintain security from the standpoint of subnetworks. So you can create security based on subnetworks, and it doesn't matter where they're at, because you can move them to different switches throughout the network.
well, it would depend, well, I wouldn't agree with that statement because who's gonna facilitate their IP address scheme on the end station?
That's right.
DHCP
Right.
DHCP,
or-
it has to be
Okay, so then when you do that, they're gonna be DHCP still saying what IP subnet they're going to,
Right,
right?
so you can't do
But
that.
their IP subnet, that's why you got the IP subnet on multiple switches. That's the whole reason that the IP
Right,
subnet's
on the backbone though. I
No,
haven't
in the
tested
ports.
this. Well, I haven't tested the ability to say IP, let's say for instance, this network here is 96 and this network here is 96. I haven't tested that for functionality because the DHCP server is gonna maybe have a problem with that. Depending on, I haven't tested that, so right now I wouldn't say that you would want to have you wouldn't want one IP subnet spanning multiple switches, unless it's the backbone. This isn't the backbone. These are two different unique segments. If it's the backbone, yes. If it's two unique segments, I'm not quite sure how I'll react. Because think of it this way: if I'm sitting here, right, and I come in here, and my DHCP server is over here, and I'm a PC, I'm going to intercept it and I'm going to forward it to my DHCP server, right? And then I'm going to send it to the server, and he's going to send it back. The question is, when it gets back to this switch, since it's in the path, how's he going to handle it? Will he know what to do with it, or will he just throw it out over there? Because he has no knowledge of this guy over here, right?
Sure he does.
No, he doesn't. He has no knowledge. That's a local IP subnet. The only way he would have knowledge is if you created a static route, saying, hey, that subnet's over there.
But you have to have a static route. If you, anytime,
No,
after you add the VP lands, you have to go back and add static routes to all.
Only from these guys' perspective.
Right.
Okay, so if I'm network 96 here and I'm network 96 here, right? When the packet comes back, he's going to say, oh, network 96 is local. I'm going to throw it out here. I don't know. I haven't tested it. It's bridging, so I'm not quite sure how it would react to it.
Wouldn't he build an ARP entry or a MAC address entry from the originating station?
Yes, he would. And then it'd probably be unicast.
Well,
I'm not
Could he
saying that it
determine
won't
from
work.
the
It's
ARP,
gonna come back unicast anyway.
could he determine from this ARP cache that instead of going out the local port, that IP destination address isn't
He
out
doesn't
the
have an
subnet?
IP address
He doesn't
yet.
have an IP address
Doesn't
yet,
have
because
an
remember,
IP
it's all
address
MAC
yet.
address
I
based.
think you cause a level of confusion. I think it may work. I'm not gonna sit here and say it does, it doesn't work. I have to prove it out. But
Pretty powerful if it works.
How hard's it gonna be to set up, Dan?
Yeah.
You wouldn't know, how would you want to distribute the IP
It's
address?
sub-night,
Well,
but-
that's my
It would be a
point.
mix. because you wouldn't know
Yeah,
what
I think it's-
range belongs to
Right,
the
I
site.
think it's gonna be rather ugly. I don't think it,
Layer 2 switching does to the layer 3.
you add a level of complexity, I see the value added, I just don't know how it will all play out. You would treat this like you would treat this a routed network.
How about if you define the engineering has a certain.
Anybody
number of
else have
subnets?
any point of views? I see you smiling back there. He's saying I'm staying away from that.
Hardware-based routing, guys.
Well, Dan, let's follow a packet from the originating station. He comes up, powers up, he's gonna send out another. Or he's gonna send out a DHCP
Discovery.
discovery. okay,
Correct.
Which is a broadcast, correct?
Correct.
Okay, so he forwards it out, but the source address is him,
Yeah, but
right?
right, source address is
So the
him.
first switch gets it, he says, oh, out this port, this source address exists,
He adds it
correct.
to his bridge table.
right? So then he says, well, okay, this has gotta go to the DHCP service, and it's the discovery. So he says, well, I know to get to that, I have to pipe it out this backbone port. So he forwards it out the backbone port. Doesn't the next switch see it and say, this MAC address exists out this backbone port?
No, well, he will actually add it. It's bridging it as anything else. It's learn on source, forward on destination. It's a broadcast.
So then it
He'll
goes
just
back to the
forward it.
DHCP server, to a
Right.
MAC address destination. The first switch sees it and says, it's out the backbone port, this other switch owns that address and forwards it out. Doesn't even look at the IP address at that point.
Right. The only question comes into hand, I think that piece of it may work without any problems. It's your DHCP server implementation that's gonna have a problem depending on your ranges, right? You're gonna basically have two subnets, right, depending on your class assignment, right? You're going to be sharing one scope with multiple users. So depending on how many users you've got sitting here and how many users you've got to sit here, you've got to make sure that that scope can support that user community.
What is the scope?
The
What
scope-
What defines the scope?
The scope is nothing more than an IP network, and within that IP network is the range of addresses that will be available for requests that are coming in.
So does the DHCP server care what switch which switch
No,
the
he doesn't
request
care.
comes from?
No, he has no concern for that. The question is, you know, as I said before, how many hosts will you want to support? So, I mean, you might have, you know, again, it all depends on your class. If you have a Class C, you're down to 254 hosts. And you've got two different unique segments that you want to support a user community. You could, it might work, I don't know. I don't disagree with the logic. I mean, I would
If you
say
have
that
an
you
IP
can
VLAN
go for
that
it.
span the backbone. between
I
the
just
two
don't know the
switches, it should work.
dynamics of it. I'd have to test it.
Yeah, I guess isn't the question on the DHCP response from the server what the first switch would do with that response?
Yes.
Because it would have to know that that response was not really destined to him, for him.
That's right. And it should
And
be
he
able
doesn't
to
keep
know
track
that.
of exactly requests and responses, right? He just forwards them, he doesn't match them up.
That's correct.
So what it would have to do is somehow discriminate between the one that was supposed to go to the other switch and the one that was supposed to go to its local subnet. And how would it do that?
Well,
Because the DHCP stuff is really routed. It's a IP kind of,
I
Statically
think you brought
defined
up a
routed
valid
network.
point. I'm not gonna, as I said before.
I don't know if we can test it in
It
the
may
lab.
or may not work. I just need a couple hours and I could tell you if it would work the way we think it should work. It's just a question of how does direct IP react to it and how does the DHCP server is not the issue here. It's what happens along the path and when it comes back, when it hits the first switch that has a subnet that also is somewhere else in the network. I think you add a level of complexity to it. But I mean, there may be, as you said, applications out there that might be viable and it's worth investigating. So open up a trouble ticket and Bill Dooley will take care of it.
We'll build it in the lab, we'll do it in the lab.
You know, if JR was here, he wouldn't let him off this easy.
Dan,
So,
another question?
okay. Any other questions?
I don't want to drag this out, it's going on long enough.
Yeah, no, go ahead.
But I drew an analogy, in the purposes of this conversation, I try to draw an analogy to ISVP. In a sense, you're doing a function similar to ISVP because you're extending think of it as being an ISVP VLAN at the top there where it says 100 megaseconds, and then that same ISVP VLAN existing down here. See what I'm saying? So obviously all of the devices in between those two VLANs have to support ISVP. Okay, now talking about direct IP, all these devices have to be able to support extending that subnet across that, the green line where it says channel, a backbone channel. And the real question is does it support extending a logical subnet across the backbone channel?
Let's test it.
Yeah, you know, when you
That's the question I would ask the
described,
engineer.
I can't answer that because I'm a person who has to work with pitches.
No, this
So-
is the question I would ask the engineer that develops.
Right, and he would want to have, he'd probably want a picture saying, show me what you're really talking about, and then we could, you know, he could give you an answer. But we can do it in the lab if we want to, after we go through just the exercise of getting acclimated with what the process is. And then we can go off and, you know, you guys are here to learn. You know, best utilize the time, and we can kind of cut back on things if you think this is more important, and we can do that. I have no problems doing that because, I'll be honest with you, I just kind of worked my way through it. I've kind of peeled back exactly what's going on. The information that I'm providing you today was basically de-engineered. It's not advertised anywhere. You've read the white paper. It blows a lot of smoke screen at you, and you really don't know what's going on. So there was a lot of effort that gone on my part just to kind of sit back and take traces and get behind the scenes and, you know, pick the engineer's brain to try to get as much information as I can. And for the most part, it works fairly well. There's some bugs along the way that have been identified and fixed, and there's still bugs that still need to be fixed. Some of these scenarios that you're bringing up are good points, and the only way to really validate them is to go through some due diligence. And, you know, if we can't get an answer, then we go to the engineer. It's just a question of getting familiar with it.
How long
Dan?
has direct IP been available for anybody?
It's been around on other the Israel products for about 9 months, a year.
So how's the response then? Have you
What do you want to take?
done up with it?
It's a hard sell.
Yeah, well, it's usable. I mean, it's been around for 9 months. Have you guys used it? Have anybody used it?
The thing is that if you sell it to the right person, the wrong person. If you go and you tell him you can throw away your Cisco router and it's time for direct IP, you get thrown out from all the stairs.
Have you been able to do that the last time? Or-
No, we have never replaced a Cisco router for somebody that wants a Cisco router. But if it's a small to medium shop and he hates routers, and we found out he's afraid of routers, and he's got a problem of network too big, broadcast.
I understand.
This guy will buy direct IP because it's
I
easier than
understand.
anything.
But have you found anybody, any guy like that last time? Yeah, but has it been one guy or has it been? Is
Well,
that
I can tell you that South Florida is probably the largest direct IP installation in the world.
So we have.
Yeah, the bottom line becomes, I have no accounts that are using direct IP
Exactly.
properly. Tim, I don't know, do you have any accounts?
I've got one in North Carolina.
Okay, and Ed?
BNI is using it, but it was never a side of that size.
That's the answer.
I overheard what you said, it isn't working over here. I've got the DHCP server on the backbone. It's not on a different subnet. So I don't have two unique subnets hanging off of each switch. I have one subnet spanning across the whole, all 3 switches, 5 switches. What you described is slightly different.
No, with what I just said here?
No, I mean, I thought you said that what you were talking about earlier is kind of like listening.
That doesn't mean it's not a good system.
I understand. I just
It's
you
in
know,
the right.
Your scenario is what I've got here. What you're talking about
I just was
earlier.
wondering if it's been around for 9 months.
I don't have two
And it's so
IPv
good.
lanes.
Why haven't we?
I don't have IPv lanes the same
Why
on
is
each side.
every network a direct?
Only
IP?
on the backbone.
No. Right.
There
There must be a hook.
Because it doesn't do reach 2, it
Go ahead.
doesn't
Okay.
do OSPF.
Yeah, is it safe to say that once, as soon as you've enabled direct IP, IP VLAN, that you're no longer able to configure and utilize like a layer 2 VLAN scenario? Like, does that
No,
take
that's
over
not
all
true.
of your VLANs, or could
No.
you actually have
No, the
some of
only-
your switch doing layer
There is a-
3?
Yeah, there's one problem with direct IP if you have existing VLANs out there. When you create a VLAN, it defaults to all, meaning that it supports all protocols. If you try to create a IP VLAN with another VLAN, it's going to come back with an error. because it sees it as violation of a policy, because it doesn't look up and it doesn't compare. So basically, you wouldn't have a VLAN that supports IP if you're going to be using direct IP.
But you can have other things.
You can have other VLANs, but then you have to specify, then you gotta get into the policy side of it. So I haven't had a chance to really dig into that. This is obviously on the 3012. On the other products, it's slightly different. You don't have to worry about what Bill bringing up on the other products. On the 2032 or the 2024 or whatever other products you may have, because they don't do policies. 3012 does. So that could be an issue. We're still charting waters on this product. We're learning as we're going along. We don't have it totally de-engineered at this point in terms of how does everything mesh together. For the most part, everything does fairly well, but I haven't had a chance to spend a whole lot of time on the policy-based stuff.
Dan, Bill, I think asked another question, which I don't think you answered
Okay.
fully. And I asked the same question. I thought Odin, John and I are working on a deal. Can you do layer 2 switching and layer 3 switching in the same box? That's
Can you
what I heard
have
Bill
layer
say.
2 VLANs
Well, not VLANs.
and layer 3 VLANs?
Well,
So you can
simplify
have
it.
switching.
Ask it from both perspectives. Without any VLANs at all from a layer 2 perspective,
Right.
then we do layer 2 switching
Yeah,
and
no.
layer 3 switching.
Oh,
in
yeah,
the
it's
same
not an
box.
issue. Yeah, no, I mean,
So
you
you can
gotta,
group a lot of ports at one
Think
end
of
of the
it-
switch and
just
make
think of
it.
it this way, when you create direct IP, you're really creating broadcast domain. That's all you're doing, with added functionality. That's all you're really doing.
Okay.
Because if you look at what broadcast domain does, it contains ARCs, but he allows still unicast traffic to forward.
Okay, so we could have a 16-port 10100 module in a GFS.
Yep,
Ports 1 through 8 can be doing layer 2 switching.
Mhm.
Ports 9 through 16 can be doing layer 3 switching.
that's correct.
Each port could have its own subnet, or you could have multiple ports assigned to a subnet, and then other ones
Absolutely.
on a one-to-one basis.
Yep, now
Then
the
to
only
take-
thing, right,
Right,
the
then
only,
to take that conversation one step further, excuse me, sorry.
yeah,
Bill was saying, well, can you also have VLANs being layer 2 switched, as well as direct IP kind of VLANs within the same box? So,
and the answer
Which
is,
is more
and I'll
complex.
test it real quick, is, the answer is yes, but they're gonna have to be policy-based. That's the answer. Which means that you can have a security or broadcast VLAN created, and you'll notice in Megavision when you created it, it asked you what the name of the VLAN was and what protocols it wanted to support, and it defaults to all. If you have a VLAN created, and we can test this in the lab, that's been created, and then you try to create direct IP, my belief is it's gonna come back with a policy of it.
because there's no overlap.
Protocols.
Yeah.
Then it will work, but you have to do a policy base, which have to be created from the command line and not through Megavision.
Right. So your VLAN, your layer 2 VLAN, you have to back the IP protocol out of it.
That's correct.
Only configure it for any other protocol but IP,
That's right.
because there's no
Yeah,
overlap.
why would, yeah, right.
One step's
exactly.
on top of the other.
Right.
That's happening.
Yeah.
Thank you.
Any remaining unused ports in neighboring islands, was worried my policies to back up ports, and we would have them back.
Well, you should be able to still pass IP, any other protocol traffic over it. Yeah, that should be okay. That won't be an issue. That works fine.
Exactly.
Yeah, I've been able to test like this. It gets a little hairy trying to, again, I'll be honest with you, is I haven't had a chance to take a box and say, okay, I'm gonna do X, 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 and X, and see how it functions. But for the most part, based on some of the things that we've done in the lab and we're gonna continue to do, and what I've done, it seemed like it all plugs and plays really well. The only gotcha that I can tell you right now is the VLAN and direct IP coexisting as one. You have to create policy base or just don't use VLANs, for your regular traffic. And then again, unless the only reason why you're using VLANs is if you wanted to contain ports locally attached to that GFS, and it would seem to me that the GFS wouldn't be used to support end user community, it would be more to support server farms and that kind of stuff. But again, it all depends on your configuration and how you want to use it.
The maybe question again for me there, for the NBase guys, I mean, obviously you have experience with them all. The VLAN stuff that we did yesterday, is that, how common is that?
Very, very, very common.
That's almost everybody does that?
Yeah.
Okay.
Primarily in school systems and education, those kind of things.
Just like with Enterprise Hub, everybody does VLAN.
Mm-hmm.
Okay.
Yeah. Now, I will say one thing that you folks need to be aware of, and that is that the PCs today are really fast. They're so fast that if you have PCs plugged into switch ports, NBase product switch ports are all participating in the spanning tree. So if you plug in a PC that's extremely fast and he wants to, for instance, talk to a Novell server and log in, there is the potential that that client will never be able to log in because we haven't finished conversions on that port, because as soon as we see link, we go through spanning tree convergence, or we go through the spanning tree algorithm, which is we listen for 15 seconds, we learn for 15 seconds, and then we go into a forwarding state. And what can happen is, I've got a PC from a customer down in Washington, D.C., that will start sending Novell protocol packets 27 seconds after it's booted. And unfortunately, Novell is not robust enough to continue to send those packets to log in. He sends only 4, and if he doesn't get in, then all bets are off.
Same thing with DHCP.
DHCP.
DHCP
Right,
for communication.
right.
So if it doesn't get them, then it says, hey, I can't find the server. So if the switch is converging, DHCP won't, direct IP won't configure it, so.
Correct.
Yeah.
So that's an issue you've got to be aware of. You've got to kind of, and there's only,
Even if you use it as a layer 2 switch.
Yeah.
Even if you use a layer 2 switch.
yeah, it doesn't matter, right. So the bottom line is that you've got to be cognizant of the fact that you've got PCs out there that are very fast, and there's only a couple of solutions. The operating system and the NIC card drivers are not going to address this problem. I've called them. They don't view it as, it's the switches problem. And the switches, some switching companies view it as, yeah, all right, we'll take the heat and we'll add some functionality. Not that they want to, but it's the only remedy they can provide to the end users. And basically what they do is they put the switch ports into a forwarding state automatically. Okay, but then you could potentially have an outage for that one instance where you plug a switch in, another switch in. If it's already forwarding, we're gonna see a BPDU and we're gonna send it. We're not gonna actually go through that learning state that we typically would when we see link transition. So you could have a short outage for 2 seconds or 30 seconds, and then everything will be fine. So there is some trade-offs there, but you need to be aware of it. Or you can turn spanning tree off at the port level.
Spanning tree is on by
Then you take the
default.
risk of someone plugs a switch into the network, now you've got a loop network and nothing to protect it.
Or you play a 30-second AVI file before the client will review.
Well, then you can get creative on the client side, yeah.
You can find a way to do it in the driver, and let it go, and it works. To put in the.
Well, I did some manipulating, and I did find something in Novell that there's this thing called time to net that is designed for wide area links. I'm not quite sure what it does, but it has a timer on, and I increased the timer, and the user was able to log in every time, and that's one of the proposals I gave back to the customer. I'm not going to guarantee that it works in a real live network. We'll have to wait and see, but it worked here. So basically what I did for the customer is I gave them all the options. The options of autoexec.bat by doing a search on the Windows directory, I could create a 7-second delay before the drive got loaded. Or I manipulated the network client 32 time to net parameter. Or you can manipulate 2 parameters on the NBase side by putting the ports either in a fast forward state, which just automatically, as soon as it sees links, puts it into a forwarding state, or put the port into an ignore state, which automatically puts the port into a forwarding state, but it doesn't participate in the spanning tree anymore. So there isn't that many options that you can use, but just be aware if you get a call that they can't log into the network. It's mostly exclusive to Novell too, because most other protocols are a little bit more robust and they'll continue to retry.
We have it with DHCP.
Well, DHCP is just another protocol that isn't robust enough to kind of, it's the client side that's the problem, which they can fix if they really want it. But they just view it as it's not their problem, so. rather all playing in the same space and trying to, you know, provide continuity to the network, they're all
So you
kind
took out the green gates and put a 4 doors, for A equal 1 to 10,000 next A. You know, that's right?
Any other questions?
Nobody should have that problem with the NECs.
Fast fooding problem?
Right?
NT servers, several of them, for their mission critical applications, which is point of sale. You know, like in the museum, you go buy the trinkets and the souvenirs and things. And they actually used NetBEUI as the protocol to communicate with the NT server.
Can
Instead of
I ask you a
TCP/IP.
question? If you set up TCP/IP, it overrides NetBEUI on Microsoft Network.
Absolutely, absolutely. We're, yeah, well,
Okay.
for political reasons, you don't always go and tell the customer they gotta go change this on their operating system, right? I mean, we all know what should have been done in the first place. The customer's environment had, all their IS department people have turned over, left in the past year. Now they've got, the new people who have come in are not only unfamiliar with the network, but they're unfamiliar with, they're not as familiar with networking as their predecessors. So what they've got is they've got an integrator / reseller in the area who actually spends 30 to 40 hours a week on site, one of their men. They manage their cable plant and all the networking equipment, the 3-com routers, the Xyplex, and the whole works. So the reseller didn't feel comfortable, you know, as part of our solution, having to go in and say, okay, first of all, you got to change all your network, you know, when you're mission critical NT servers, we want you to change them all to TCP/IP from NetBEUI prior to doing this. We're going to try to attempt to tackle this with, you know, as it is. You know, the NetBEUI is bridged anyhow, so there's not really, that's the least of our worries, okay? Our main concern is these other 2 protocols, especially the 3 routing protocols, IP, IPX, and Alpha. So. But what they've done is whoever originally designed the network, they took a 15-slot chassis and basically stuck a bunch of fiber cards in it, some 204s, and provided, you know, fiber connections out, routed fiber connections out to these 2 core routed, NetBuilder 2 3-com routers here and here for redundancy. And then they extended. The connections. No, I take this back. These are copper connections right here. These are fiber. They took fiber out to the IDF closets. Okay. All out here and out here. There's 25. There's 25 of these closets, right? And then they'll either. This is not the norm. This is the norm right here. This is typical. They'll have a 6-slot net 9000 or a 3-slot 9000 hanging off the back of that net too. And of course, everybody's on the same collision ring, right? So to convolute things more, and may not be too applicable, but I just thought I'd throw it in here. It's, you know, they're running 3270 over their IP, which shouldn't be. We're hoping it's not going to be an issue. It's just going to be IP. They've got a token ring in there, they have an IBM host in there that sits on the token ring, and there's a token ring Ethernet to token ring bridge that's going to have to stay in place even after we do the translate, you know, after we put it in the new equipment. So that piece of the network will stay, so the token ring, the users can get that token ring attached host. I've got about just under 20 Novell servers that they're in the process of consolidating down, trying to get it down to about 10. Most of them are 411 servers. They've got a few of the 3.x servers. We also realized that we can load a TCP/IP NLM on the servers and get rid of IPX altogether. And that is going to be that's at the top of our list. We actually came up with, I didn't bring my file with me, but we actually came up with about 2 or 3 different options of how we could potentially handle the IPX in the network. They've got 16 Class C, actually registered addresses, and they have a Gauntlet proxy server that's, this sounds kind of hokey too. Essentially for the internet, they've got one address, All right? So any user in their whole network today, even though they've got 16 times 255 registered addresses that would be valid on the internet, they're going to the internet through that gauntlet, and it makes every one of those users look like that same one IP address. So that's good for us. If we're gonna migrate this to a flat network, that would be good for us. That's the way we looked at it. Okay, so that's basically it. What the idea we came up with was to replace. First of all, we're going to can all these NetBuilder 2s. Right? Customer, by the way, the customer wants to get rid of all this routing and all the complexity. They have no problem. These things have been written off. They're at least 4 years old, maybe a little older than that. Our equipment's been in there 3 or 4 years as well. So, replace these guys and put in either an SX 2032 in most cases. Actually, in most cases, and then put in a GFS, gigabit collapsed backbone device, right? And then put under NBase Xyplex connect them, right? They have spare fiber, enough spare fiber going to every closet, from this MDF closet to every IDF closet, such that we could drop a GFS chassis in this MDF and actually build a parallel network that looks like this going to every closet.
There's no fiber card for the GFS.
Okay, we've got a translator right here that we're getting from NBase.
Okay. Yeah.
Okay? Translator from NBase to go from. This essentially, this is the 10100 card for the GFS right here. All right? And we're going to have 2 of them here, 10100, and they're going to feed out to the various closets.
Where are all the servers located?
The servers are currently distributed. That's another thing we're working on. Okay, we want to get them in a server farm, them all centralized.
So does everybody on the network throughout have access to all servers?
No, no. They're currently, one of the tasks that I've given them to do is to go off and better identify who's talking to what. That's what the reseller is currently putting together a more structured list of who's talking to what, who needs to get to what. Every user that's off of each server. This thing, the customer has mismanaged this so bad that they've gone through. One of the things here is one of the reasons why they have so many addresses, and they're actually running out of address space. They think that they have other IP needs within the network, not just going to the internet. Whoever was administrating the IP addresses in the network, when a new person would come in and an old person would go out, they would just give the new person the new IP address. And keep this in mind, after years and years and years, they're eventually going to run out of IP addresses. Well, that's what happened.
Why don't they gut that out and just come up with an address that you in-house?
Yeah.
Get that proxy thing there and then let them facilitate the internet address and give them a Class B address.
Yeah,
All the problem goes away.
This is one of our solutions, was to give them a flat, or give them a Class B address for
You're
everything.
not using them for what they're supposed to be.
That's right.
for yourself.
Right, Class B address was one of our solutions across the whole board inside, on the inside of, in the intranet.
Larry, why do you want to use the GFS? Are you going to have gigabit uplinks into servers?
That's something that is going to be for future, not initially, but and possibly in the future.
How many IDF closets do you have to feed?
It's about 25.
What kind of apps?
Why not put in like a 5 or 5 HD?
There's no imaging. There's no.
It all depends on the apps, how much traffic.
Yeah.
Well, if it's all 100 meg, put in a 5 HD, and if at some point you need to put gigabit services in, then put the 3012 in and do a gigabit uplink from it.
How much of that is 4270 emulation of our IP?
It's minimal. It's probably 10% or less of the traffic.
Rest is a client server.
Most of the traffic is IPX. And the reseller says that they have very little. There is little to no, big files transfer. It's not file transfer. None of the applications are file transfer. like.
Well, if it's all
inquiry.
POS, it's all client server model anyway. There's no file transfers to POS.
Oh, yeah, no, that's just called POS. POS is not the only application that they have.
But didn't you see that was the main app?
That's the main, that's right, it's just
And that's the one that runs on
that's-
that GUI, and you're gonna
That's
see.
right,
you
that's
modify
just, the
that.
POS is, just like you said, it's just transactional.
Transactional anyway.
Yeah, just.
What's the IP
Little
address?
spurts of, lots of little spurts of data, and that's the POS thing, so.
What's the IPX application?
We need to find out more about that. We don't have that pinned down yet. Yeah. Like I said, that's some of the homework that I'm giving the resale. But here's the concept. Let me tie the physical part of this together. It's difficult to administrate all the, because of the IP addresses and the, all the routing that's going on to the customer, it's difficult to administrate.
Well, there's been no complaints or issues.
I would think there would be.
Yes, there's been some, because they're all coming through this one. Oh, another thing that was a problem is they had a power outage not too long ago, and this NIK didn't come back up. So that was ouch. That definitely is a factor that's driving these guys to look into upgrading the network. That and the difficulty of administrating it and all the other factors.
So all you've got in the N9K then is 210.204?
That's right.
We're just using this big.
It's just a giant Ethernet
Oh.
concentrator. Yep, giant Ethernet concentrator. And that's our position out here too. We don't have any routers in this customer's network at all, bridges, wires at all. So what we were looking at doing is tying this GFS down here with one connection. And this is why I'm bringing it up to you guys to see if we can come up with some other ideas. There's going to be a bottleneck for a while because this is going to be 10 megabits. Okay? Build a parallel network, tie them both together with a connection, okay? And then cut over and close it, right? Get rid of that net builder 2 and just get rid of these things. And just say this is, because this is the typical, this is typically a 9K. And then take and segment these 202s to their own switch port on the 2032. So you've got a maximum of 24 users per collision domain now, right? Per segment. Okay? So bring those in, 4 copper connections. These are co-located. Just bring them right into there. 100 base FX back to the GFS. And then if they still need to get to, they will still need to get to resources that are on the old network. They'll have to come across here. This is a problem. I mean, but we couldn't, right now, we could not think of any other way to do this without having to go sticking 100 meg in here and having to put money into this. They don't
How
want
many
to.
ports do you have? 6.
In this box?
Yeah.
What is this ABC? Where is it going?
That's the segments.
These are the 10 internal 10
You have
meg.
users, you have internal users, sir?
There is a few, I didn't show them. The primary function of this box is just to act as a concentrator for all
It's a
these.
hub, right? One big hub.
Right.
And the ports are 10 megabit each.
Yes, everything in here is 10 meg.
Okay, how about if you took the 2 routers, put them on a switch, right from the beginning?
Right.
But
On
these
a
two
10 100 port switch.
up here?
No, either there or just another switch.
How many
Couldn't
ports do
do
you
that
use?
until you redesign your layer 3 stuff first.
See if,
No,
No. I
no.
said you
got
got
two
2 routers
on each
to
side
the
of the
segment.
network.
That's just a repeater.
what he's saying is put them on a switch.
Yeah.
Yeah, and remove that central connection. Put all the 3 ports into the switch. All the 6 ports coming from the
But aren't those
router.
2 routers representing unique IPX networks on each side of that concentrator?
What does it matter? The switch doesn't matter. He doesn't care, he's just gonna forward traffic between the routers.
And
Well,
even
the
if
thing
it's
of it
on
is, yes,
Set VLAN, okay?
this is a
Well,
net.
you create a security VLAN, but you increase the broadcast domain. Right? So now you-
Not more than what you have now. But at
Well,
least,
no, I wouldn't agree with that. It's being contained at each router, the broadcast domain.
and what happens
It's
if
being
you put them on
routed out
a
in particular, well, the switch will, you'll have 2 networks sitting on one flat network.
Yeah, see, this is a routed connection. what he's saying, this is a routing connection.
So on the other side, on these two
What other
sides,
side? I mean, right now you
those
have,
fiber links.
well, wait a second. You have the top line there, right? It says net one, okay? Net one goes to C. Connects the two routers to themselves, if I understand correctly. Correct? Net one is connected to both the left router and the right router.
Yeah, this is for
Segment C.
redundancy purposes.
Wait a second, and to segment C. Let's look at each separate. You have one line connecting the two routers and the segment C. You can create that same connection on the switch. You're not creating more broadcast there.
The traffic coming out of each one of those segments is being contained to that routed network.
Yeah, but it's contained in the switch as well.
Not in the ARPs that are coming out.
Why would the router be ARPing on another network that it doesn't?
It
that's
doesn't
what-
have,
If
you
you
see,
remove
you
the
connect
router,
one
the
here,
ARP gets
one
contained
here,
at the
and
router.
one to the segment,
You
right?
pull the
This is what
router
it
off,
is.
and the ARP gets flooded.
Yeah, I understand. This is, but this is exactly the
The router stays there.
Those two ports,
Oh, it stays in the
remove this.
front.
Yeah.
Well,
Remove
that's-
all of this.
Oh,
Just wipe this off. You got three routers, three ports of this router,
I thought you
three
said
ports
replace the
here,
routers
and
with
three
a
ports
switch.
that go to the existing network.
with the switch.
Then, you know, here, this is net one. This is net one. And then you make another port that goes to the actual units, net one, times three. And that VLAN is net one, net one, net one. When you have more broadcast than you had before.
Well, if the router's staying in the picture, then that's.
Yes, for the time being, for the user. Before, but you don't have to, beyond this point, everything.
Oh, I
you
agree.
can do.
I thought we were gonna pull the routers out.
No, no.
Yeah,
Yeah, eventually, yeah.
eventually, but this could be a good, migrate, that's what I'm looking for, ideas to
Will that
migrate.
by itself
Right.
increase the bandwidth? Think about it.
And then,
Right now, you have each of the routers its own port, its own 10 megabits.
and then you're proposing then to connect
No, no.
the new parallel network to this network, just tie the
Absolutely.
connection from here.
How many ports do you have in that big Ethernet concentrator that are being used for each segment?
Let's see, well, there's enough for the 25 closets, each
So
of
there's
those,
25 ports?
at least, and then there's some users, there's a couple cards in there, copper cards in there for
Okay,
users.
the bottom line that says net one, it actually goes back into the N9K. As used as a hub. The bottom line that says net one,
Oh, yeah,
it
yeah.
goes to the users, it actually returns to
Right. And then
the card that provides up to 25 units.
210, 203A.
Right.
This is to the users,
Right.
okay? So we got this connection right there.
Hey, Larry? What you do is you remove the routers from the
Okay.
NIK.
Well, we're removing this, keeping the router, initial, for phase one then, what you're saying is put the switch in place of this.
Yes.
Right, and tie this GFS,
Into the switch to
and switch uplink
Yep.
at 100 megabits. That gives us the 100 megabits instead of being choked at 10 megabits that we had here.
Right.
Great, that's what I'm looking for here. All right, so what about this up here then? Does anybody got any ideas on this? Does that look good? Does that look bad? Is there any other ideas?
We're on top.
Well, if you only got 10 megabit segments running out there, I don't know why you're putting GFS in.
I mean, that's a GFS. See, that's the second thing. That switch at the bottom is a GFS.
All you need to do is actually take that GFS out and just use that 316 card if you want the fiber. Or
Yep.
you got your 100
Is
megabits
the
now.
first GFS you got drawn on top also in your DF, is that co-located, you're drawing there?
Yeah, yeah, everything here.
But
Everything
my-
on this board is.
Okay, my idea was that switch on the bottom is a GFS.
We just,
GFS is the problem.
Or a card that
what
you
I'm
have
hearing
to
from
the-
Phil is that if there's no 100, what I think I hear from you is that if there's no 100 base T to the desktop, why do I need GFS?
Exactly.
Is that necessarily true then? I mean, should you take that philosophy? I want to put something in there that is ahead of the customer and think that, in 2 years from now, they'll have 100 base T to the desktop and,
So
even though they may not be stating it now, I want to be a couple years ahead.
So you're still there, if you own the 5K, and you run 100 meg out to the IDF on fiber,
5K's not shipping now, is it?
HD, yeah, it is.
It's shipping now?
Yeah.
It just started shipping.
Yeah, 5 HD with the 100 meg fiber card in it.
So that's another
But
option.
the 2032 H,
What's the long-term routing strategy?
Everything is
Are you
fine.
looking to flatten out the core?
Flatten the whole network out.
Flatten the whole network.
Yes.
They couldn't have it if they're gonna put switches. Unless they can do.
Yeah,
Do you need to feature some of those GFS policies, et cetera?
Well,
You wanna get
what
off
the
that?
thinking was, is, and this is another reason the GFS was put in, was the GFS and the 2032 seemed like the ideal components to put in there from another standpoint, because they supported direct IP. They both supported direct IP. They both seem to fit well to support the physical topology requirements, but as well as the direct IP, and using the direct IP to gracefully flatten out the network. Okay. Some of the, you remember the drawing I had up here a second ago that showed another net builder 2 hanging there, and then say a 3140. Okay. You know, he's going to get rid of all these.
5000 HD in the center.
He's going to start flattening out these subnets back here and consolidating them, you know, by straightening out, using he's got variable length subnet masks all over the place back in here now. He's going to start backing off that subnet mask and consolidating those users into a single subnet back here. Okay, so that's going to be something that is a prerequisite before we even drop the 2032 in.
Why do you want a 2032 and not the 2024?
Why do we want 2032 instead of 2024?
What kind of traffic are you expecting?
Well, first you're gonna find out if the servers are gonna stay local or distributed or, call them back to the center.
Right.
Because until we know the bandwidth flows, the size of the pipes don't really much matter this time.
Right. By the time this is 100% implemented, the servers will all be back to one.
If everything's gonna be on the hill, then you wanna have fat pipes out to the edge.
Also, the switches that you're designing are all backbone-based switches, which could be a lot of overkill, like without your edge stuff should be more of a work group switch.
You can set it for the 2024.
Unless they got tons of money, they want to spend everything, then that's a great solution.
How many users in the concentrator right now? You got, how many?
There's not a whole lot of users in here.
Okay, so
All the users are out here.
you're out on the edge.
Yeah, there's just a few. There's a couple of these 210, 238.
2032 in the center,
Yeah.
2024 in the edge.
Yeah.
Unless you can sell the 32.
Say, as an alternative, this could be a 2032.
Yeah, not there, but on the bottom.
Down the bottom.
Down,
Core,
right
maybe
there.
2032.
There, and without the GFS.
2032.
Yeah. And then you can put the
And
final
you got
ports way.
and a 2024 out here.
Yeah.
And the advantage is you don't need the 316. Straight
So right now you haul your fiber right
into 2032 in the center.
This hasn't been available until recently
It
either.
is available.
I know, but it's just recent.
Okay.
I mean,
Well, we're talking about what we have now.
okay, to my knowledge, I mean, this is shipping now.
Oh, yeah.
This is Xyplex branded products.
And the 2032 has Apple models as well. Fire.
This doesn't have direct IP, right?
Yes, it does.
It does?
Yeah.
You making notes of this, John?
That was one of the boxes we looked at.
Okay. So we could use a 2032 and a 2024, both of these, okay. So we can cut down the price on this.
You'll be the king.
Hey Larry, do you have any idea what percentage of the traffic is IP versus IPX versus Apple Talk?
He's doing that, he's collecting those statistics now, but from what he's told, I've asked the same question. Apple Talk, there's about, he said about 70 to 80 users. What they're doing is they've got Macintosh stations communicating to Novell server. They're using print and file services off the Novell server. They don't have an Apple Talk server.
So are they using
But about 80
Apple Talk?
users, about 80 Apple Talk.
So it's the minority. The reason I ask is IPX and Apple Talk are both pretty chatty, and by putting switches in there, you can hurt yourself.
It's Ethernet, not Apple.
You know, because now all of a sudden you've got broadcasts going across the network, especially if the servers aren't centrally located. So that's why I was curious. How about the IPX? Is that the majority, or is that?
Yes, IPX is the majority. IPX and IP are the key, primary traffic is those two protocols. Yeah, there's 20 Novell servers.
What's ideal segment count in the middle? What kind of segmentation ratio do you want in the middle?
What kind of segment?
Number of switch ports desired.
In the middle? Well, we know there's gonna have to be 25, right? Because the 25 closets. 25 of these uplinks right here.
Every time close it,
That's 2500.
from the router.
So that almost maxes this guy out, right there.
Well, you could put, well, you need 25 for the closets and then what, another,
Yeah, we could, well,
this.
Wait, see, the way you build it is you replace an IDF with a flat network, then you free the port that goes to the router.
right there.
Yeah, get rid of all those megabits into the router, right?
You'll
100 megabit one.
remove the routers, right?
Actually, I told you guys wrong. There's another room over here, a computer room. This is actually just a big closet, a big MDF closet. And we have tossed around the idea of putting a gigabit module in here and coming over here to the computer room to another GFS. And having the server farm here. This is, we tossed this idea around. Okay, so how would we do that without using the GFX? Just put, if we had all this on a data,
There's not enough information. You got 25 fiber links coming back into the core on both sides? 25 here,
total
25.
25.
Okay.
Yeah.
They're all set up.
So all those 25 in the new network would be coming in here. We use the GFX. Okay? And then, see, this would definitely need to be a fat pipe then. Right? If they took all the distributed servers and stuff them in there, that would be justification for a GFX.
Well, you'd have to take a look at the application flow, the amount of data you're passing, and what kind of file servers you're using. If you're gonna put AT-bus file servers in there, you don't need 1,000 megabits per second, no matter how you command you put it in there, because you can't pass that much data across the pipe to the AT-bus.
Are they gonna upgrade their PCs from 10 meg to 1000?
Not initially.
So the servers must also reside on 10 megabits, right?
That's right.
So why you putting a
Right now.
1,000 megabit pipe in, and have 10 megabit servers, but are only gonna push a 1 megabit per second maximum anyway?
You want to design it to scale.
Hold back 24, retention flow. 20 seconds.
25 total.
What's the user count in each second?
24 per second.
You get the IDF, 2032. How many users out of an IDF? You're segmenting within the IDF.
It varied. Some of these chassis only had one or two 202s, which would be either 24 or 48 users, and some of them had as many as 4. Actually 5. Some of them were maxed out, 30, 125 users. So anywhere from 25 to 125 users per IDF.
Is there a geographic issue here? With this, is it one building?
Huge, yeah. But the fiber, it's not, I mean, they've got fiber running today over 10 megs, so if that works, whatever else we put it, it works.
Yeah, but you put 24 users, you put 24 users on one minimal segment size, you already don't need anything more than 10 megabits to run. Right? So the 2024 is actually, how are you going to utilize it? How are you going to distribute the ports from the 2024?
If you don't bring any major bandwidth improvements, you still got some people.
Can you break the N9K to smaller segments?
Sure.
Standalone.
How?
Smaller than 24?
Per card.
Yeah,
24 per card.
like 4. 4 and
No,
then
you
separate
can't.
segments.
No.
No.
So you can break them down into 24.
Each card can be on its own.
Right now, the whole chassis.
No, it shares the ABC segment.
Or
external.
or disconnect
Isolate
it.
them.
This is
That's the user
isolated.
bus, but then you feed
Well,
the outside.
today what it is they're all in the same
They're not
internal. Today they would all be
You never
connected
solve
to the A
anything.
segment,
Right.
and then they'd have one connection coming out of the A segment to the round.
Okay.
Okay?
That's
We're
all
gonna
right.
go,
There's
go
always a
from
better
that
way.
That's right.
to isolating each of them and having separate copper connections.
So you would see some.
If you put the 2024, then each card will have its own,
Dedicated
24 users
server.
already per segment, or per port on the 2024.
That's what I wanted to do. Yeah, I mean, you can do the
Is
same
that
thing.
enough?
Yeah, you can do the same thing. It's no big deal. 2024 is the exact same thing.
It's a kind of an overkill.
Or is it?
2016?
And if the servers remain distributed, be fair bandwidth wise to the edge users to the pop.
Why have a 2016 with
This is not cast in stone yet, because he has fight back with his network analysis of how the tools are distributed with the servers.
Why don't we make a little of that stuff, Bob?
You need actually 4 ports.
Yeah, so why not put a 2016 in? It's gonna be cheaper.
You want to go down to the 210 there. Right? The 215 may.
Okay?
Number one, the
I'm
server
talking about
location.
black box stuff.
Not that it really matters.
I'm talking about base box stuff. I'm talking about black box stuff. There's something from his black, right? I'm not putting base stuff in.
I
We're
know,
black.
I like the black box better.
It's pretty.
All right.
Traffic.
The green lights really show.
It'd be overkill in the network if you're making them pay like 2 times the amount that they really need to.
Look, are they looking into kind of add more power to the edge, which means replace the NIK?
I don't think they know what they want to do. They just want to minimize the administration.
1026.
That's about it.
Suppose you put.
No, but they want that, and they do, would like to increase the size of the backbone. I mean, it's a 10 meg, right? 10 meg backbone.
Whatever
This is giving them 100 meg.
You won't have the user at the end.
That's right.
If 24 users are, I mean, if they're trying to plan in some new applications, and those applications require more bandwidth, there is not much bandwidth provided with 24 users sharing a 10 megabit link. Even if it ends up with a gigabit. See, if you're talking about copying a file, CAD/CAM or I don't know, graphic, browsing the internet, that the bottleneck will go back to that card in an N9K at the end, not at the center. So no matter what you do in the center, or how many servers you have there, those 24 will still compete on that little bandwidth between them and the network.
Yeah, but isn't that the whole idea of when you revamp a network, you build it up here, and it always pushes it out towards the client and the server.
But you have to go into the plan.
Look, start again.
And then you beef up the client, and then you beef up or first you beef up the server,
For
put 100 meg into
instance,
them.
if you were to put the 234s, for instance, and remove the N9K, you'll be providing 10 megabit per user.
Oh, we don't want to remove the N9K. That's the
Put the
political
switching
part
card.
of this. The
Okay.
N9K, we want to preserve
Then
their
remove the
investment.
hub card and put the switching card in there. It's 10 megabit port.
Put a switching card in the N9K.
Everything stays transaction oriented. 24 users per second is really not.
Let me re-emphasize it. We didn't want, number one, we didn't want to have to make any changes to the N9Ks whatsoever, if possible. We'd rather put new equipment in front of the N9Ks and build up the core of the
The
network.
first decision
And
is
and
to
that's,
get rid of the hub, not to the N9K.
this is the only N9K we'd be getting rid of.
No, to get rid of the hub function of the N9K.
Can't.
Okay?
Well, you
Yes,
can
you
do
can.
switch.
You put a switching card and you provide 10 megabit
Well, first,
Yeah,
it's
you can.
to each user.
But then you're paying a premium to add functionality to a chassis that we made an investment in.
4 years old. Yeah, it's
So-
4 years old. Again, I can't
It's a
emphasize enough,
catch-22.
we did not want to, the selling pitch in this deal is being able to preserve their existing investment in N9K without having to put a lot of additional money into upgrading.
But you'll
Okay,
have them
switch plane.
disappointed very soon, because whatever you do there in the rest of the network, and any money you put in the rest of the network, you're still not solving, the individual PC. Because usually when we say we want to solve a problem, we don't say you have to replace your 10 megabit with 100 megabit, but we do say you better increase the bandwidth at the end first, before you go. Then you worry what do you do with the aggregate traffic in the center. But if you put the center on a gigabit, and you still have 24 users sharing 110 megabit, they will never have a performance.
That's right.
But I don't think that that's the number one issue right now. The number one issue is to redesign the network so that it becomes flat. I'm not looking for a performance boost. It will come down the road based on the infrastructure they laid
Yeah.
today, and then come back a few years later and say, listen, the infrastructure's there. Now gut out these network 9,000,
Right.
make another investment on your end station.
Right.
So the cheapest thing would be to put a 2016-2 FO.
Whatever.
They don't need more than 4 ports anyway, do they?
2016?
2016-2 FO.
Which is 28, because they're only doing 10 megabits.
Well, you want to kind of
Yeah,
lay the
but,
foundation
they
so
will
you can
eventually-
scale later.
They will have cards.
And the difference in cost can't be that much.
No, when they buy new PC, they will definitely get the 100, 10
Right.
So if you put the 2016, you need 4 ports for your existing cards. I mean, at maximum, four for the hubs, and then you have 12 or 10 more ports of 10100 for power users. Don't take my ball. Hey,
Pardon me?
it's my ball. Bring it back.
My ball. I want my ball.
Okay, you know what? For you, my bail.
Yeah,
Okay.
So, one thing I want to make a comment about though, is that, they will have better performance than they do today.
Definitely.
I mean, even taking into consideration, I understand what you're saying. What you're painting is, you're painting the picture of the ultimate network, right? The perfect network, that has.
We have to do it step by step.
Right.
If we start, and you sell the 2016-2FO means integrated fiber. Okay? Integrated fiber, low uplink, lowest cost per edge. 4 ports, you put into the NMK, and then you still have 10 ports left over for power users and maybe servers right now.
Okay.
And they can be on 10 over 100. That will definitely, if they have local service traffic, it will increase the.
Yeah, plus the point of congestion with the design now is the ABC segment. They have one segment supporting X amount of users. By
So
taking each slot and putting it on 2024, you increase the bandwidth
Right, this old
substantially.
with just one connection for them, there was
Right,
congestion.
so we are taking.
And this was
two
congested.
sides.
Yeah.
Right? This is
You
congestion.
got a solution?
Yeah, you want
Each
to
of
get
these 3 mid-plane segments is a congestion point today.
Go say.
Larry, think about it like this. Think about it as if you're peeling an onion. Okay?
Yeah.
You don't peel an onion from the inside out. You peel an
That's
onion
what we're
from the
doing
outside
here.
in. So you leave the 9Ks in place, put a 2016 2FO in. So you got 100 megabit pipe fiber running in, and you got 10100 copper out in the IDF box. Detach
They buy the
the
chassis
202
today and do the
from the
upload.
internal segment, attach it externally to the 216.
And then
So now you got 100 megabit pipe coming
Move up to
in.
gigabit, then they
Some
reap the
flat.
benefits of that. but
Now
cost
put a
comes
100
down.
megabit card in there,
And they've already got the
so
infrastructure.
now you flattened out the network. You got a 100 megabit switch inside, you got 10100 in the outside. That will make your network flat.
You say use a 2032 in the.
No, but
I use 5K
buy the hybrid today.
with a 100 meg fiber card in it.
And then when you.
It all depends on how many connections you got coming back and what you need.
Well, you've got 25 connections, you got 25 IDF closets.
Right, but you see, you can also look at a 20, 30 megabits on 316s if you want to convert that to fiber as well. That
Well,
would,
that's extra modules.
Right. But
They don't have a problem.
whatever works the best. for
Yeah,
you.
they don't, let me ask you, doesn't the aggregate bandwidth of the 2032, isn't it better than the 5K?
The 2032 is a backbone switch, the 5K is a work group switch or an edge.
Okay, you're doing
Okay,
your thing.
so the 2032 looks like the ideal thing to put in the center of this line.
Well, right,
2032
but again,
with the
look,
2016s at the edge.
You have to look, yeah, you have to, when you get to that point, when you bring everything back and diagram, you look at
Yeah,
that.
we got 25 out of those 32 ports on that 2032 will be used immediately, and what's left over, the other 7, I could have concentrators coming off of those switch ports.
but also take a look at your file servers, what you have right now and what you're planning on getting to. You know, if
Yeah.
you're running an AT bus file server, 100 megabits per second, it's gonna put maybe 1 megabit per second maximum
Yeah.
through it.
Yeah, we're gonna identify all that.
What's that?
I've got nothing but-
You ever see a 100 meg ISA card?
No. That's what I mean.
32 would be the bare
So
minimum.
why give yourself all the performance at the core when your file server's only gonna push a maximum 100 megabits per
Imagine one thing doesn't work. You're throwing everybody out the edge.
Optical switch, yeah, they wanna go gigabit, if they really wanna go
It's not
gigabit,
necessarily
put a
bad.
gigabit chassis in the center.
There's 2012, but 2016 is cheaper.
It doesn't change anything.
Phil, aren't you asking for trouble by flattening that network if you run an IPX and Apple Talk on a backbone? I'd be afraid of broadcast problems, because now you got routers that can filter that. If you flattened all that out. If it was all IP, I'd say yeah, but IPX and Apple Talk, especially where your servers are spread
There's a
all
lot
over
of
the place.
yakking going on.
Yeah, but with the routers in there, you're
The
protected
routers
from
filter
it.
it out.
Right, and if we flatten it all out, we can fix one problem and cause another.
I don't know. I mean, the only thing, if you got 10 servers, on that network, they're sapping every 60 seconds anyway.
Well, if-
Routers are
Kevin
sapping.
really pushing the 20.
Also,
You can change the sap
We
rate.
don't really need
Yeah,
that
but
much
the
for 40 minutes.
routers will filter that, and then the proxies,
There's only 4
things like that. I
modules.
mean, the-
Five. There's still 5 modules on the Mac.
The routers keep from going out over the backbone. For example, they keep it from going across the 9K chassis. Now if you flatten all that out, yeah.
They have to propagate it to the other side.
As long as this box,
They propagate it, but they don't propagate the side.
Yes, they do.
if he flattens out
Every
this
single
this
one.
back end.
The default is the same. For an IPX router, and every server is an IPX router as well.
Yeah, but if that were the case, you wouldn't need routers and IPX networks, you could use bridges.
I see.
We won't know that kind of detail until he does it. We don't have that information this time yet. We won't know that.
If you take a look at,
It's gonna take a lot of.
I mean, you know, in a LAN environment, I don't know what you really achieve by IPX routing, except that you isolate all the other stuff. The IPX traffic doesn't change a whole
The
lot.
size of the measures.
Except for the workstations.
But not, that doesn't
And they
necessarily
broadcast,
require.
that doesn't propagate.
Okay? I didn't say anything about
Oh, okay.
From the server point of view, and the routes, all, that's
Well,
the same.
for example, it's not just the SAPs, it's the GNS requests and things like that. And that's what the routers become workstation. Right.
Yeah, this,
But
the
now,
bridge
for
network.
example,
this-
they would go
We're gonna
out
convert
across
this to a
the
bridge
backbone.
network.
Right.
All
So
those
I'm just
protocols,
saying your level of
it'll pass
broadcast
along.
traffic would go up.
We can do it with
Not
the
only does it go up for your IPX, but it also goes up to your Apple
Yeah, I'm
Talk.
talking,
I think
well,
I think
I
you
don't know
have
if
to
we
each
have
every
to
10
have
seconds.
necessarily
So I'm just saying you have two really chatty protocols plus.
only if that was a concern, what Bob brought up about the Apple Talk
I would
broadcast.
just be afraid,
If that became a
especially where you
problem,
don't know what the traffic
I'm
patterns are.
concerned, then you have to go out and do an
It's
inventory.
not supposed to be 1,000
Every
users,
single
it's
Apple Talk
only
user,
500,000
client,
users.
out there, you know,
I wouldn't want you
and
to
then what
say,
port
yeah,
to
we're
connect
flattening
to.
this out.
And then,
Just
They-
not
then
real
they
good,
would
you know,
have to
serious
be on
sniffing
their
around for it to find out.
because if they were on
Exactly
concentrator,
where all the
and some of these
traffic
people were
is.
IPX
I still want
users,
the routers.
and he was the only AT user, then, you know what I'm saying? You can't.
Yes, if you're risking it. Maybe you're right, maybe it would work, but I don't know if I'd want to spend a lot of money on a
Yeah, that's the
50
thing that I've got
proposition
you
or
already know.
working.
That's, the level you're talking about is beyond the information we have right now. Yeah. I just wanted to get, based on the information we have right now, what would be the ideal, you know. See, initially, all he's gonna do is flash it. And then he's gonna be routed from this part back. Okay, so it's still routed from this part back. And we're gonna replace this with 2016.
Better
We may
off
have to
putting
do,
some
you know
switches
what I'm
on the
saying?
edges, kind of like what they've said. That's right, cords, the hardware-based routers, do something like an Apple
So what this might do, these two routers here are layer 3. These three can literally be set up.
Well, layer three switching is a router.
And this can go, that's what Jim.
Even more?
One router. Now, people ask.
Started at 7 hall, so we put it at 3 then?
Right, that's what I'm saying. So I wasn't.
I hadn't heard actually.
Step one.
Okay. The only thing that might help.
Last I heard was just where he's ready.
Yeah, so that was there, that's running for marginal improvement in throughput, and I have a kind of a problem.
We'll take a break after the Tim show. Okay.
Yeah.
I guess the other price is small.
Yeah, please.
They did say 20, 30 or something, $5,000.
Basically, this is kind of going to be a little bit of another open session, kind of just share some application stories with you, and talk a little bit about concepts and where we've been successful on the NBase side of the house in terms of moving, basically moving a lot of bits around. Maybe talk a little bit about strategies, how we get into the RBOX, CLEX, the telcos, cable companies, power companies, gas companies. All these people are potential long-haul carrier service people that we get into some of the dark fiber. You'd be surprised at the number of people and the kinds of people that are getting into the fiber business and offering these dark fiber services. There's a lot of little-known secrets in a lot of your major metropolitan areas. You really got to get out there and start doing a lot of prospecting. It's a total different vein of prospecting as far as what I'm trying to discover where these potential opportunities are. Right in our own back door here in the Boston area, it's a little-known fact that in all the T-tunnels, the Mass Transit Authority, there's 128 single-mode fibers at every T-station running for the entire city network. There's probably only about 20 fibers in use that the MBTA has farmed out by mass government. This talks going on all the time. It's basically, some of the commercial people are starting to get in on the fiber and they're provisioning that out. The electric companies too are stringing a lot of fiber, cable companies and so on. North Carolina, Charlotte area. If you take a look at the city of Charlotte alone, you've got so much major competition in fiber there in the city and the county of Mecklenburg that you've got 2 cable companies, each drawing their own fiber. You've got Duke Power with their set of fiber. And now you've got the gas and the water utilities now pulling fiber all around too. So you can go shop fiber around. If you don't get a good price from, they've got 2 cable carriers there alone. If you don't get a good fiber price from one, you go to the other. You get into a bidding war, and you get into fairly inexpensive dark fiber in the cities. So a lot of the people that are out there are looking for these dark fiber services, but they don't know exactly how to approach those carriers to provision that dark fiber. So here comes people like NBase Xyplex along to start planting these little seeds. Here's what you can do with this dark fiber. You get in and start talking to these cable companies and things. We've been very successful in dealing with a lot of the CLEC elements in the telco systems. These are basically the co-located exchange carriers that are there by law. Anybody else can go and apply for co-location with major carriers. As a result of about 3 years of applications being on file, you're starting to see multiple CLECs and ILECs pop up everywhere. And what they're doing is they're, of course, not only buying dark fiber from the RBOC, which the RBOC has provisioned by law to the CLEC to give them a certain number of dark fibers. The CLECs are getting smart and they're putting high bandwidth equipment on those fibers and bypassing carrier A services. And it's become a terrible, incredible competition issue between the major RBOC and the CLECs that are out there. And they're sitting in racks that are 6 feet apart in the same facilities. But the CLEC and ILEC components are the ones that we've been extremely successful with in terms of getting a hold of that dark fiber and lining it up with gigabit Ethernet. A little bit of news hit the press yesterday. Through the efforts of NBase and 3012 and that type of technology, they made a formal announcement yesterday afternoon to Teleport magazine. It's a fairly popular telecom magazine. SNET's position now in gigabit Ethernet that is an official standard of the company. They're going to offer gigabit Ethernet services to their customers, as well as put all their data services on gigabit Ethernet, any bulk data services on gigabit Ethernet in lieu of SONET traffic. So they're starting the gradual process now of offloading the SONET network and pumping that over to gig backbone between the COs. And it's pretty impressive, and I think it's a milestone for the company, MRV, NBase, and Xyplex. Everybody's going to get a piece of that action eventually. So some good news there. So let's talk a little bit about some of the past successes that we run into.
What was the name of that publication?
Teleport magazine. I haven't seen the article yet. I just found out about it this morning. Keep your eyes peeled for that. If you see anything, snag your copy. Leverage the heck out of it. Guys in marketing have already started the ball rolling on that to try and leverage that news and get it out to you so you can use that as a reference site for that. So, tell you what, while we're on that particular issue, instead of talking about some of these individual applications, just hop down to SAT and I'll share that story with you first. And we'll talk about some of the others there. This is the Southern New England Telephone Meganet. And basically, part of this is conceptual, and I can tell you what's installed and what's installed so far. Southern New England Telephone basically is a single operating telephone company just within the confines of the state of Connecticut. As many of you know, they've been recently bought or in the process of being bought by SBC. SNET basically has a bulk of their business along this corridor here. If you start up in the Hartford area, work your way down through Wallingford, New Haven, Bridgeport, and Stamford. This entire corridor here probably represents more than 50% of their entire state revenue in terms of telecom and datacom. They call this the golden banana. That's basically where they get all their basic revenue. The entire central office count in the state of Connecticut for each city is about 145 central offices that serve all types of services, all the data services, telecom, and everything else. The major COs, of course, are in the major COs like Hartford, New Haven, Bridgeport, a couple of places up in the far reaches here that are considered major COs. What NBase has done so far, and proving out, this has been like almost a 6-month evaluation cycle, is that we were successful in getting initially 2012 technologies installed in all the major COs along the Golden Banana. We did a stretch that runs about 70 fiber miles between these 5 major cities, and we planted 2012s in each one of those operating offices. This week, the transition is being made to 3012s in those major COs, and we start planting those devices in there. So we're running a gig between each of the major 5 COs. The plan at that point, as you see here, wherever you see a 3012 plopped in here, we're going to fan off to a switch 10100 service to some of the smaller or minor COs out in that vicinity here. Here we intend to pick up all the independent ISP bulk traffic at each one of those locations known as POPs, haul those back to the COs, assign them a VLAN, dump them onto an aggregated VLAN on a gig Ethernet, haul them back up to Newington, Wallingford, Connecticut, and do all the core routing at that location there. We already proved a lot of that out in carving out VLANs and offering those individual services. Topologically, let me show you what we did in terms of the actual network that one of us as a business, besides having the capability to run long distances, we, strangely enough, we're able to close the deal using VLANs. Somebody asked earlier about, yeah.
Why don't you go on the paper one and everybody probably
He's gonna die. That's why we brought Mark, get used to it. We take a look at this Golden Banana. Here's the corridor here. And each of the major cities, we planted a 3012. We actually demonstrated this with a 2012 first. Each of the ISPs as well as SNET is also an ISP. They're offering basically dial services to individual users. But along this corridor, they, in each of the individual COs, they were experimenting with various edge technologies. Number one, they were looking at LAN City and Motorola and everything else, and cable modem technologies, for one. Number two, they're also currently looking at some DSL stuff too, for last mile type of connectivity. The first thing we demonstrated was with Motorola cable modem technology. Say, for instance, up here, this location of Wallingford is where they're basically, we're picking up UUNet there. We're pumping that into a router. The back end of that router is a switched 100 megabit port we assigned VLAN 1 in there. So basically, they're paying for one UUNet DMARC in Wallingford. By assigning that VLAN 1, now they're offering switched 100 services and peeling off that UUNet directly at the ISPs along that corridor there without having to pay for additional DMARCs from UUNet. Number one, cost savings. Number two, for fault tolerance, they picked up Tier 1 ISP number 2, which MCI is sitting here. And they assigned that to VLAN number 2. They took all these individual VLANs now, and they some kind of big friggin' router sitting there doing all the routing between the two of them, between the VLANs like this. In each one of the remaining COs, they're peeling off another switch 10 megabit service going into the cable router. Back into the cable router, there's broadband. That's going out on the poles, dropping off individual cable modems out to the user. Here's Joe Blow down here setting his PC like that. What sealed this whole deal, they liked this so far, but the one minor thing that seemed to seal that deal was, why not create a test channel, a VLAN? We took one of these modems, pumped it back into, say, port number 8, created VLAN number 8 here. Now that VLAN is totally separated from the production traffic going out to the COs. They can sample in-station data by coming out of VLAN number 8 down here, and take a look at total system latencies, throughputs, and so on. Somebody called about port